So thank you very much, everyone, for coming along today. That was a fantastic presentation from Ash there. I learned a lot of things in there, and I'm going to have to update my scripting knowledge because I'm a very good TCL scripter, but I've not really dipped my toes into Python. So yeah, I'm looking forward to doing some of that in the new release. What I'm going to be talking to you about today, though, is around our block modeling toolsets within Surpac. So it's going to be a bit of a masterclass. I'm going to talk you through what is our structure, how does the block modeling work, what you can do with it, what you have to be careful of as you go through it. So let's get started. So the first thing is to do a quick review of what is the Surpac block modeling format. Well, our main format, you'll see it when you create your models, are the MDL models. We do support and read other models like free-format block models and competitor model formats, but MDL is the one that's built for Surpac and works within Surpac. It's a fundamental component of Surpac. It's been there since very early releases of Surpac. What it's done is it's based on what we call the octree format. I'm going to give you a bit of a dive into that in just a minute because it's a very important way of structuring block models or structuring data in general, actually, to make it very quick to access that data, very quick to report on that data, very easy to store that data as well in terms of the file efficiency and the sizes. Okay, and it gives us some nice controls over being able to make blocks bigger or smaller depending on where we want them to be. We also take within Surpac a dynamic approach to sub-blocking. So our sub-blocking is never really fixed. Our sub-blocking changes depending on the constraint that you apply to it. And the block size also changes depending on what you store within that model and how those blocks relate to each other. Okay? Something that's not always well understood in the Surpac methodology versus the competitor formats and competitor methodologies that are out there. So our blocks will change their size based on where they are, based on what they have inside them as well. It's highly efficient. Okay, if you've ever looked at the difference between a Surpac block model and a competitor format block model or CSV output from a Surpac block model, you'll see it's night and day between the two. Okay, orders of magnitude difference in terms of the sizing. Okay, and the reason for that is because we utilize a number of speed ups, a number of clever little tricks inside of the model type to make that as efficient as possible. But at its heart, the reason why it's so fast and so small is because we only store the data that we need to at the resolution that we need to store it at. Okay? And I'll give you a deeper dive into that. So by having models that are like this, it means that they are already relatively small. And if you zip them, they get even smaller, which means that they're very quick to load, very quick to use, easy to share, and small in terms of their file sizes. So let me give you a bit of a view into what did I mean by an octree format. Well, octree is the heart of how our system works together. Okay, it allows us to store only the resolution required and not add detail where we don't require it to be. Okay, and it means that for each block, that block can be divided into across all of its principal axes. Okay, that's the basic level of an octree format. And it means that you take a standard block, if you divide it by 2 across each of its axes, you're going to end up with 8 additional blocks inside it. And that's why we call it an octree, because we divide it into 8. Now, it's a very hierarchical setup, but it's a very efficient setup for it as well, because it means I don't need to store the coordinate values of every single block. I don't need to store the resolution of every single block. I don't need to store the block size of every single block. I know where it is because of its relationship to its previous level on the octree, and I know what size it is based on which level it is on the octree as well. And that's hugely important for the programming side of things. Okay, it makes it very, very fast to be able to retrieve that model, makes it easy to spatially segregate it as well, so that when we do things like constraints, we know exactly where we are, and we are able to generate those really quickly. It can also be irregularly split. So in standard octree, you would only be able to split it by 2 in every single direction. That's not the case inside of Surpac. We can do irregular splits. It means we can split it by 8 levels in the X direction, 4 in the Y, 2 in the Z if we wish to. Okay, and we will still get a very good output from it. Okay? But the limitation to it is that the subdivision must be based on half the previous level. You can have multiple levels, but you can only divide into each time. So it means if I've got a 50-meter parent block, I can split it up into 25 meters, 12.5 meters, and keep on going all the way down the line, as small as I want to. And there's no limit in Surpac for how small you want to go. You keep going, keep going, keep going as far as you want it to go to. But I can't ever take that 50-meter parent and split it into a 5-meter block. Okay, that's not possible because it's not a regular subdivision by two, a base two, if you'd like, of that 50-meter parent. Now, hopefully these aren't revolutionary things for most of the people here, but it's important to keep that in mind because it's one of the easiest ways of creating poor quality models that don't reconcile the way that you want them to. It's also incredibly important when you're dealing with importing data from competitor formats where they don't follow the same kind of subdivision. So if you are working with different tools out there, if you can get them to build their sub-blocking on an octree compliant sub-blocking setup, then your life will be very easy inside of Surpac. You'll be able to transfer data very quickly and very easily. So that's the idea behind an octree format and why we utilize it, because it's very quick and it's very efficient to be able to store data in this level. So how do we use that practically? It's nice that we have this computational power in the background and that it's doing all of this stuff, but what does it actually allow us to do? What are the tool sets it allows us to do? Well, it allows us to do two things. It allows us to have sub-blocking and it allows us to create super blocking. Okay. Now, sub-blocking, everyone is very familiar with and very comfortable with how it works. You create your minimum sub-block resolution at the creation of the model, and the model goes off and creates those sub-blocks where it needs to, based on your geometrical constraints. So surface constraints, solid constraints, polygon constraints. Plane constraints are also in there, but plane constraints are fine. They can also be utilized within this. So you set that sub-block resolution at the start of model creation, and away you go and use it. But not everyone's fully aware that that's not the lowest resolution we go to. It's not the highest precision we can go to inside of Surpac. When you're reporting, you can go beyond that minimum sub-block into even smaller blocks if you want to get higher precision against your geometry constraint. And what we also do is, on the other side of things, we do super blocking. Okay? So let me walk us through on the video of what that looks like to just give you a bit of a comparison point. And then what I'll do is I'll come back. So I'm going to load two models here. Okay, and because I'm in the newer releases of Surpac, I can have two models open at the same time. That's a beautiful thing about the new releases. So in this one, we've set up a user block size at 12.5 by 10. And I've got a sub-block size going down to 1.5 meters. But if I click around and look at these blocks, well, I can see, well, that block's a 50-meter block, and that block over there is a 25-meter block, and that block over there is a 1.5-meter block. Okay. As I look around at these different block sizes, I've got smaller and I've got larger blocks. So how does that work? Well, the reason for that is because we are utilizing super blocking. And what super blocking does is that if all of the parent block sizes, those user block sizes, have exactly the same value stored within their block model, then what it's going to do is it's going to aggregate them together into a single block. And I'm going to store one value instead of multiple values. But it will also store it at a sub-block level if within that structure I've got different values. Okay? So on that one down the bottom there, all of those blocks contain the same value because it's just generic waste in the bottom corner, and I don't need the resolution in that bottom corner to be able to do what I'm doing. There's no point in me storing in here a large number of different blocks, okay, if I can instead store it all inside of a single block. Okay? And that means that I get a much more efficient block model storage. I get something that's much nicer, much faster to do everything that I want to do with it. Fantastic. But I still am going to need that sub-block resolution at different times. And it's important to understand when we will turn those super blocks on and off. So super blocking happens automatically. If it can be aggregated, it will. Okay, but that doesn't limit us in any way. If I put a constraint through it, which I'll show you later, you'll see what happens to those blocks. It is possible, though, to disable the super blocking. Okay? And that's what I've done on the second model down here. Okay? So this particular block model hasn't got any super blocking occurring on it. Every single block in here is either at the sub-block resolution or it's at the user block resolution. And the reason for this is because I've got a unique value in here for the IJK value. And that means that every single block has a unique value. And because every single block has a unique value, it's not possible for Surpac to super block it. And And it means that you will instead get something that works like so. Now that's important because this model is going to be a lot bigger because it's not able to be more efficient in its storage. And as we work through larger and larger models, it's useful to know when are you slowing Surpac down and when are you letting it speed up. Okay? All of the material in this bottom corners in this waste model down here, I don't really need the resolution on the user block size. It'd be better if it did super block it. So I need to be careful about which attributes I'm storing within my block model, which may result in super blocking being disabled. So it's an important thing to keep an eye on and look at how it works. But you'll see here the sub-blocking is never affected by this. The sub-blocking always retains the values that were stored within them based on the constraint that was used to create those super blocks. And so if you look at one of these ones over here, you'll see that they're inheriting the IJK value from their parent block. So using the octree format, we're able to do that, and we get a dramatic improvement on the efficiency of the storage of the block model. It's normally about 3 to 5 times on average, but it can be a lot more depending on your block sizing and depending on the attributes that you've stored. Okay. And in the example that I just showed you there, we've got some blocks which were super blocking up to 200 meters off of a 12.5 meter sizing. Okay. So that tells you that you've got a storage efficiency in there of a very large set, about 16 times. Okay. What that means is that for a single block that we were storing with super blocking, if I put it back to a regular block sizing, I would need to store 4,096 blocks for it. Okay. So I'd have to store an additional 4,000, almost 4,100 values inside of my block model for something that Surpac originally would only be storing inside of one value, one block. Okay. That's why we get the efficiency. That's why it works and does what we want it to do. So this is part of the structure that we try to do with this to make it work. So if we've got super blocking and if we've got sub blocking, that's lovely that we've got all these different block sizes, but how do we maintain support for estimation? Okay, when I'm doing estimation, I want to report into a block size. Okay, and I want that block size to be based on my sample spacing, based on my support. Okay, so how can I make sure that I'm doing that and I'm not getting weird things showing up in sub blocks where I shouldn't be having them? Well, the way that we handle that is that we have our own definition of an estimation block size. Okay? That's within the estimation form, and we're able within this to specify what is the size at which the calculation for estimation should take place. Okay? And using that defined estimation block size here, we perform all of our statistical analysis, we perform all of our discretization, we perform all of our estimation into that estimation block size. And then we store it within the block model at the resolution that it requires. So if you end up creating an estimation that is quite large, let's say that we were estimating at 50 by 50 by 40 blocks, okay, then that's where it's going to super block to, providing there's no other conflicting information in the model. Okay. It's also going to apply those and store them within the sub blocks where a constraint exists. Okay, where it goes through. So sub-blocking is applied at time of reporting. It's also applied at time of constraint. So if you are constraining the estimation, that sub-blocking will store values within them. But it's the most efficient way to do it. So fantastic. But what about reporting? Okay. We've got this situation here where we've got this very large block. How do we handle that? Well, the whole point of dynamic sub-blocking is that it creates the sub-blocks where we need them to be. Okay, it does the work for us upon that. So if I've got a fantasy surface like this cutting through a very large super block like this, I'm going to make a choice here to constrain it. So firstly, we're going to take a look at this block. That's an enormous sub-block here running at about 200 meters by 200 meters. And that's the resolution that the data is being stored at. There are other ones, 100 meters, 50 meters, all of that stuff. But that's the resolution that we're storing the data at. So if I now sit there and select this surface and use some of our new features around quick constraints and say, quick, give me a constraint below this surface, it then goes off and runs its sub-blocking routine using our octree hierarchy and builds out what should that model look like there. Okay? So it's constraining all of the blocks down to my minimum sub-block resolution. Okay, to get me the resolution on the contact that I need. And that means that blocks right on the very edge are going to be at my minimum sub-block. Blocks at the higher level are going to be super blocked together to be more efficient. So that's the methodology that we use within this to make sure that we get the best possible precision where needed, and that we don't go to that level where we don't need it. If we then chose, though, to go to reporting, we could take it even further. Okay, so the constraint tools will take you down to your minimum subblock, the one defined in your block model, but that's not the smallest size that we can go to for the purpose of reporting. Okay, if you wish to report and get into even more granular detail because you're not getting a good resolution between it, that's what our geometrical grouping tools are for, and that's what our on-the-fly partial percentage function is for. So if you chose to group between DTMs or report within a solid or report within a string file, you can then apply a precision across this to increase beyond the minimum subblocking. Okay? And each of these precisions is essentially dividing your minimum subblock in two. So it means that you can subdivide your minimum subblock effectively by a factor of 32 in all directions, because we can increase it up to 5 times. Those extra subblocks only exist for reporting. We never store them. Okay, they're only there temporarily to allow us to generate the outputs that we need as quickly as possible and to get the precision that we need for it. So this is the way that we structure our modeling on purpose to allow us to have the larger blocks where we need them to, smaller blocks where we don't need them to. And when you look in the summary of a Surpac block model, it'll tell you in there the number of blocks. Okay? People have often shown that to me, going, that's the number of blocks I have in my model. Not quite the number of blocks you have in your model. What it is it's the number of blocks that are stored. Okay? And that means it includes the super blocking efficiency. So if I've super blocked 4,000 blocks up to 1, that number in the summary will only show you the 1 that's been super blocked to. It won't show you the actual user block resolution. So it's just a small tip to keep in mind when you're looking at that summary page and trying to understand what that's saying. That's also why you have a storage efficiency calculation directly beneath it, because that's showing you how many blocks have been super blocked, what kind of storage efficiency are you gaining off of it as well. Okay. So what are some of the tips and tricks here? Okay. How can we make it better for us? How can we work with these bigger and better block models that we keep getting? Okay. Well, if you want to get the last parts of performance out of your model, you want it to get as running as fast and as efficiently as possible. The key thing to remember is make sure your super blocking isn't disabled. Okay. If you need to have unique values for each block, use a calculated attribute. Okay. Try to keep away from individual block values like IJK values or coordinates as explicit attributes in your model. Coordinates are stored in the background. You can inquire those as you need to, okay? But don't store them explicitly as an attribute within the model, else you're going to disable super blocking everywhere. And if you disable super blocking, your model size is going to increase quite a lot. To give you an idea of what that looks like, if you've got a super block model that's running at about 100 meg, okay, if you go and drop in that individual IJK value like I did, it's going to jump that block model size up to about 360 meg. That's on my example data set that I was showing you there. It will be a lot more impactful on bigger data sets with more attributes inside them. The other thing that people do sometimes when they're saying, the block model is too big, I need to define it at a smaller level, is to constrain the block model. Okay, so to remove blocks that you don't need or don't want. Okay, people do this all the time. They sit there and clip away everything above topography and say, I'm going to build a constraint model with nothing above topography. I'm just going to have everything underneath the topography and store that because I don't need the air blocks for the purpose of what I'm doing. Okay? It's not a bad idea, and it can work if you do it effectively and if you do it correctly. But you are normally better off to use a plane which will align with an octree format than you are to use a topography. And I'll show you that here. Okay? So in this example, if I took my block model and I constrained it with my topography and only stored the blocks that were constrained by the topography, instead of a 100 megabyte model, I get a 180 megabyte model. And that's a bit confusing. Why did the number go up? I removed blocks. Okay, so if I remove blocks, surely the number should go down, not up. Well, the reason why it goes up instead of down is because you have disabled the super blocking in that location. You have told it to store the sub blocks all the way along the topography contact. Okay, so that it can retain that resolution and utilize that resolution downstream. So by doing such a thing of constraining the model by a geometry like a topography, you've actually increased the size of your model, not reduced it. Okay? And that will happen quite a lot when you do this kind of work. What you're much better off to do is instead find out above a certain plane, which is compliant with my standard block sizing. Okay, so I don't go into my subblocks at all, I just go on my user block sizing instead. That plane is where I'm going to clip. Everything above that plane I'm going to remove as part of my constrained model. Okay? That's absolutely fine. If you do that, you won't disable the super blocking in that area. It'll be able to continue using it, and it will give you a much more efficient model, and it will cut down the size of your model. But this is something to be careful of. I see people using this all the time, saying, I've already got my ultimate pit shell. I'm going to remove all the blocks outside the ultimate pit shell. Or I've already got my topography. I'm going to remove everything above the topography. If you disable the super blocking, you will see an increase in your block model size, nearly always. Okay. The other thing to do is to reduce the number of attributes wherever possible. Okay, so each attribute that exists must be stored in all blocks that exist. So if you have a few erroneous attributes, you quickly jump up the size of your model. So if you can reduce the number of attributes, please do. If you can't, no, then you have to live with what you got. Where possible, avoid the use of competitor formats, but this is not always possible. I'm well aware that you can't always get away from this. Okay? But if you can, try and get your competitor third-party format model, DataMine model, Micromine model, MapTech model, whatever it is, try and get it to be in a regular block sizing that's octree compliant. So divided by 2 every time. Okay? If you can get that, you'll be able to input it into Surpac very, very easily. That's the first thing. And the second part about it is that you'll also be able to utilize the super blocking and the sub blocking schema. Okay? But if you can't do that and you need to run on what you've got, you can, but your model's going to be a bit big and a bit sizable and a bit complicated to move around. If you can't live with that because the model is too big, then I recommend that you use the new user-defined reblocking tool. Okay? And that reblocking tool allows us to reblock from competitor formats into an MDL-compliant structure, octree-compliant structure. It also allows us to do irregular sub-block conversion where you've got different divisions and different axes. And if the model is truly enormous, okay, and I'm talking 10 to 30 gigabyte size block models, okay, and you're starting to really see issues within Surpac, crashes on certain functions, the software crawling to a halt in some areas, there are a couple of things you can do to try and gain a little bit more stability. So one of the things that I would consider on it is to reduce the number of logical processes that you have in your default preferences and the system options. Because the way that Surpac works on its constraints, its reporting, its estimation, is that we use multi-threaded estimation techniques. It means that we basically take the block model and pass it out to multiple different cores on your machine to do all the processing. It's really good, makes it really fast. Okay, it's a fantastic way to do things. But in order to send it out to all of these different processors, it needs to take a copy of that block model into its memory. And then once it's got a copy of that block model into its memory, it takes it out onto the different processors. So if you have 12 logical cores or 12 logical processors that are running for it, it's going to take 12 copies of your model into memory to be able to distribute them out to all of the areas that it needs to use it in. And if you've got a 30 gigabyte model and you try duplicating it 12 times in memory, I hope you've got a lot of RAM because you're going to run out of space. So the technique to use in that area is to instead reduce the number of logical processors. Okay, step it down to 2 or 3 instead, which will allow you to not run out of memory in that situation, but it will slow down the process. But sometimes you've got to do what you've got to do with enormous models. I also recommend that you reduce the use of display functions until after your constraining has taken place, or to use sections instead of 3D to display. And if you're really stuck, switch to displaying as point clouds instead of blocks. But that's some of the methodologies that you can use to get faster and faster models. I would also consider, now that we support multiple block models, looking at splitting your block model into multiple models instead and utilizing the multiple models inside of Surpac, because that's also a very efficient way of doing it if you've got truly enormous models. So that's a quick overview from me. I just wanted to show you some things that I think aren't particularly well understood, perhaps in the Surpac community. If I didn't teach you anything today, that's fantastic. That means your trainer did an excellent job with you the first time round.